Alright, today's video is going to be about measuring angles. Okay, so angles are one of the most important building blocks of geometry. We're going to use them, you're going to see them a lot throughout the rest of the trimester. Okay, so what is an angle? An angle is formed by two rays with the same endpoint. The rays are the sides of the angle, and the endpoint is called the vertex of the angle. Okay, so this symbol is the angle. I call it like a lopsided L. Okay, so to get you a picture of what an angle looks like, just a basic one. Well, it helps if it's straight. Alright? So usually when you see angles, you're going to have 3 points. This one is the vertex. Okay, and then these would be the two sides. Alright? Now, naming an angle is very important, and you can do it in 3 different ways. Okay? One way is you start with one point and then work your way through the other ones. So if I were to name this angle, I would start with the angle symbol, and I'm going to start at X. So I'm going to go to X, go to Y, and then go to Z. Okay? Get rid of that. Okay, the second way, let's say I don't want to start at X, I want to start at Z. I can do that. So I would start at Z, go to Y, and then go to X. So Z, Y, X. Now, notice, which point is in the middle? It's the vertex. Anytime you name an angle using all 3 points, you have to put the vertex in the middle. It's just what we do. Vertex in the middle and the 2 endpoints on either side. Now, if you don't want to use all 3, you can just label it with the vertex. Okay, this is kind of like a general form using just 1 point. To be more specific, you use 3 points. Okay? And again, over here, I can do that. C is the vertex, so let's say I start at M. I would go M, C, P. I could go P, C, M. I could do I could do just angle M. Get that out of the way. There we go. Out of the way. Not just angle M. What am I thinking? Just angle C. Now, there's another way you can do this. See how on this specific example there's a number 1 on the vertex? You can also name an angle by that number. That doesn't happen all the time, but if it's there, that's an option. Most commonly, what I want y'all to get in the practice of writing an angle, I want you to use the 3 letters, okay? So, big thing here. The vertex point is in the middle. Okay? You cannot start with the vertex and then go out to the other 2. You start with one of the points out farther and then go to the vertex and then go to the other point. Okay. Let's do this again. Let's name the indicated angle in 2 different ways. So I'm looking at angle 1. Where is angle 1? Now we have to be specific. We have to pay attention to these numbers. Angle 1 is right here. Okay? It's not all this. There's technically 3 separate angles in this picture. There's one labeled 1, there's the one labeled 2, and then there's the big one that's all 3. Okay? We're just focusing on the one labeled angle 1. Okay? The vertex at angle 1 is going to be the B, so we're going to have to start with either the A or the C. So we can say angle A, B, C. So look, if I drew that, go from A to B to C, that kind of borders my angle 1. Okay? And then if I can go backwards, C, B, A. That's 2 options. Alright? Angle 2. Angle 2 is the smaller portion. So again, B is a vertex, so I could say angle C, B, D, or I could say angle D, B, C. I can go backwards. Okay? Notice how super important it is when we label things. Okay? If I just said angle B on this problem, you would have no idea which angle I'm talking about, because angle B could be 1, 2, or the entire big thing. Okay? That's why these letters are super important. And you have to get yourself in the habit of naming angles appropriately with your vertex in the middle. Notice B is the vertex, it's in the middle of all my examples here. Alright. Now, there are different names for angles based on their measures. Okay, here's 4 examples and how we classify angles. If your angle measure is between 0 and 90, so it could be 10, 55, it could be 89.999. As long as it's between 0 and 90, it's called acute. And I like to think it's acute because it's small. You know, small things are usually cute, so small angles are acute. If it is exactly 90 degrees, not a hair less, not a hair more. If it's exactly 90, it's a right angle. Kind of like the corner of a room where the 2 walls meet. If it's between 90 and 180, so 91, 100, 179. If it's between 90 and 180, we call it an obtuse angle. They're generally your larger angles. And then your angles that are exactly 180, you can draw this little half circle on them. Those are called straight angles. They basically make a line. Okay? And then just for fun, here's an extra angle. Let's say, right here's my vertex. If I measure an angle this way, so if it's, let's say, whoops, X degrees. If it's between 180 and 360, we can call that a reflex angle. You won't see a whole lot of reflex angles. I just threw that in there for fun. You have to know these 4 names. You got to know acute, right, obtuse, straight. Those are the biggies. Okay? Now, remember we talked about segments, that if we said if 2 segments have the exact same length, they are congruent segments. Similar idea with angles. If 2 angles have the exact same measure, we call them congruent. And remember, the symbol for congruent is an equal sign with a squiggle on top. Alright. Big thing here. Just like we had with segments, we had a segment addition postulate, we have an angle addition postulate, okay? So, here's 2 ways you can see it. If point B is in the interior of AOC, what that means is, right here's angle AOC, AOC. This point B is inside this angle, so it's between these 2 rays, okay? Then the measure of AOB, so this one right here, plus the measure of BOC, this one right here, is the big one. Okay? So it's kind of like what I said earlier with segment postulate. We have piece, we add another piece, we get the whole thing. Okay? Now, a special case of the angle addition postulate, if AOC is a straight angle, which means from A to O to C, I draw this little half circle, then AOB plus BOC, hang on, AOB plus BOC will give me 180. It's the same thing as this, it just happens that the AOC is a straight angle, 180. Okay, this is what I remember. Piece plus piece equals whole. Piece plus piece equals whole. Alright, let's put it into use. What is, now, see how there's a little m right here? When you see little m and then angle and then some letters, ABC, that's asking you for the measure of that angle. Okay? So what is the measure of angle TSW? So I'm going to go over here and look. TSW. I want that piece right there. What is the measure of that if the measure of RST, so let me label. RST. They're telling me that angle is 50 degrees. We measure angles in degrees, by the way, so 50 degrees. And the measure of RSW. Well, what's RSW? Change colors. RSW. That's actually this entire big angle RSW is. They're telling me RSW is 125 degrees. Okay? So we're going to have to use our angle addition postulate here. We can say the measure of angle RST plus the measure of angle TSW should equal the measure of angle RSW. Okay? See how you can already see how important it is that I label everything correctly and how these labels are important. RST is what I want. I'm going to plug in what I know. I don't know RST, so we can, you could call it that, or you could call it X if you really wanted to. Now, we know what TSW is. Whoops, no, I lied. I read the problem wrong. I'm sorry. This is what we want. Plus X. RST. They told us what RST was. That's 50. They told us RSW is 125. Sorry about that. Now, subtract 50. If I can do math right, that should be 75 degrees. Now, pay attention. I put a degree symbol on here because this X represents that. So let's just say the measure of TSW is 75 degrees. If I ask you for a specific angle measure, I need to see this degree symbol down here on the end, okay? If later on when we're using just variables, you may not necessarily have to put the degree symbol. But if I ask you for a specific angle measure, I need to see degree symbol. Because otherwise, I don't know what kind of 75 you're talking about. You can be talking about inches, miles, or whatever. But if you tell me degrees right on the end, I know you're talking about degrees. All right. If the measure of DEG, so DEG, this piece is supposed to be 145. What's GEF? Okay, if we look close enough, I can draw that half circle. That means this is a straight angle. Okay, so the measure of angle DEG plus the measure of angle GEF should equal the measure of angle DEF. Plug in what we know. Whoa. I think my board has a touchy spot. 145 plus the measure of angle GEF equals 180. Subtract 145. Oh, I've dropped my pen. Okay, I'll get it later. So, 180 minus 145 should be 35 degrees. Okay. Now, when you pair up angles, sometimes they have special names and special properties that come with them. Okay? So here's 4. Scrolls down a little bit. Okay. Vertical angles. Those are two angles whose sides are opposite rays. So, in this picture itself, there are 2 pairs of vertical angles. One pair is 1 and 2. And the way I tell myself about vertical angles, if I see an X, like X-Men, see an X, I know that the ones directly across from each other are going to be the same. So 1 and 2 are vertical, so they're going to be the same. And then the other 2 are the same. Okay? So there's 2 pairs there. That's vertical angles. And coincidentally, if those 2 across, let's say this angle 1 was 130 degrees, that means angle 2 is 130 degrees. They have the same measures. And if this 3 was 50, then this 4 would be 50. Okay? Adjacent angles. Those are 2 coplanar angles, which means they're in the same plane, with a common side. So like right here, they're sharing this side. Well, if I can draw on it. A common vertex, they're sharing that vertex right there. And they have no common points. So there's no points over here that are shared over here. It's kind of like if you take 2 angles like this. Let me see if I can do this. You have 2 separate angles and you kind of swoosh them together and you get kind of overlaid this piece onto this piece, if that makes any sense. Okay? Adjacent angles will always touch. They'll have a shared side. Alright? Whoops, wrong way. Let me... Oh, shoot. Okay. Let me erase this. Scroll down. Now, these 2 are my favorite. 2 of my favorite pairs, okay? Complementary angles. No, that's not spelled incorrectly. That's how we spell it in mathematics, okay? Complementary angles are 2 angles. When you add their measures up, you get 90 degrees even. Okay? And you'll see it 2 ways. You'll see one way where the angles are adjacent. In other words, they touch each other. And they add up to 90. Or sometimes they don't even have to touch and they can add to be 90 degrees, okay? That's an important distinction to make. They don't have to touch to be complementary. They do have to touch to be adjacent. Okay? So down here, if we were talking about these angles, these 2, this pair right here that I've got circled in red is adjacent. This is not. But they're both complementary, okay? Each angle is called the complement of the other one. So let's just say we have an angle out there that's 75 degrees. Okay? What would its complement be? So we want to know what its complement is. I would just take 90, subtract 75. That would be 15 degrees. That would be its complement. Okay? Supplementary angles are the similar idea, except they add up to 180 degrees. So when you add them together, they'll make a half circle if they touch, or when you add their measures, they add up to 180. And then each angle is called the supplement. So if we have an angle out there that's 100 degrees, his supplement would be, whoops, back up just a second. If one angle is 100, his supplement would be 80 degrees. Okay? Scroll this down a little bit. Alright, so we're going to name an angle described based on what we have here. So, We want an angle that is supplementary to angle AOD. So I'm going to go over here and look. I'm going to find AOD first. AOD. Now I'm just going to label that myself. Okay? So AOD is all this green arc right here, okay? Now, that angle itself is two angles in one. This box that you saw earlier indicates that we're talking about a 90-degree angle. If you ever see this, you see that box? That's talking about a right angle that's 90 degrees. Okay, so this is 90 already, and then that's 60. So this whole arc is 90 plus 60. That's going to be 150 degrees. Okay? I want to find an angle that when I add its measure to that 150, I would get to 180, because that's what it means to be supplementary. That means I'm going to be 180. Well, if I look, I already started this arch. If I continue it down to this ray right here, I get that half circle. Okay? So, what's the angle that is this little arch that I had to draw in? It would be DOC. So, supplementary would be DOC. Angle DOC. Alright? Let me erase this. Adjacent and congruent to AOE. So, where's AOE? AOE. AOE is this right angle right here. So I want it to be adjacent and congruent. So first let's remember what adjacent means. Adjacent means it's got to share a side with one of these, with the angle. Let me label where the angle's at. I need to share one of these sides, and I want to be congruent. I want the same 90-degree angle measure that AOE has, okay? Well, you can look back just a little bit. If you'll notice, if you go from CO to E, from COE, that's another 90-degree angle. And angle COE shares this side OE. That's what my answer is going to be. I'm going to say angle COE. Alright, erase that. Part C, supplementary to EOA. So I'm going to find it, EOA. That's that 90-degree angle again. And coincidentally, my answer is going to be the same thing here. AOE and EOA are the same angle. So that it's 90. And we found out earlier that COE is also 90. 90 plus 90 is 80. So therefore angle COE is supplementary with EOA. Right. Part D. Complementary to angle EOD. So I'm going to label my picture. EOD. It's just the 60 part now. Okay? What's it mean to be complementary? That means I need to add up to 90. Well, in my picture, what's going to make me get 90? It's going to be this little sliver right here, DOC. So angle DOC. Okay? Last one. A pair of vertical angles. So I need to look for angles that make me an X. Well, if I look at this picture, I see that this and this make me an X. So I would say angle AOB and angle DOC. Or COD if you wanted to. Okay, those are vertical because they will make me that X. Alright. Now we're going to find specific measures. So find the measure of the following angles. EOC. Let's scoot this down a little bit. EOC. EOC. If I look close enough, EOC consists of a 60-degree angle and this little sliver. Well, if I can draw that little box, that means it's going to be 90. So EOC is going to be 90 degrees. Okay? Now we're going to look at angle DOC. So DOC. Angle DOC is adjacent to, no, wait a minute. I don't want to say that word. Yeah. DOC is adjacent to the angle before from EOC. If you look inside, you can see that there's already a 60 there that makes EOC. What was the sliver left? Well, 90 minus 60 is 30, so this angle is 30 degrees. Okay, now they want the measure of angle BOC. So BOC. Now this one's weird. Okay? We want to go from B to O to C. It is all this business. Okay? It's a B angle. Well, we already know this is 90, this part's 60, and this part's 30. All we have left is this little piece right here. How do I know what it is? Well, if you look closely, this 30 that we've labeled and this one right here, they are vertical angles. They're across from each other. So they have the same measure. It's 30. So I've got a 90, a 60, and two 30s. 30 and 30 is 60. Another 60 is 120. 120 plus 90 is 210 degrees. Okay? And the last little angle they want is angle AOB. AOB. That's that 30-degree angle we just found a minute ago. Okay? And I just realized I forgot to put your homework problems at the end of this video, so I'll make sure to put what problems you have to do on the Google Classroom assignment. Okay, I apologize for that, but that's all you need to know for measuring angles.